Hey, it's Coffee Compiler Club on Thanksgiving or the day after. Everyone's in a food coma, me included, so there's no one here. Oh, it's not fair. There's only four people here, so it's a short meeting. Um, I was talking about how I don't have a way to have a Java process talk to a browser tab without opening WebSocket, and no one had a WebSocket for free unless you bought into some ginormous, huge uh, frameworks like Spring or something. It's like, no, 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 no. I don't want that kind of thing. I
Maybe
just want to
you
open a
can
socket,
try. Maybe you
pass.
can try Neti. Neti.
Sorry,
Maybe you can try Neti.
Nate.
Neti.
Oh, Netty.
Yeah, Neti. Okay.
Um, yeah, I was gonna show this first. I mean, I got it sorted. It just
Mhm.
it burned a day. If I
Mm.
pull in one of these frameworks, it'll burn a day as well.
Yeah.
There you go. Too tall, Nate. I looked at that one. It had some issues,
Mm.
Matt. I totally went and Googled my way around. I followed this thing, and I couldn't figure out what it was going to suck in that looked ugly. And what it ended up with, I'll show you guys in a minute. What it ended up with was like 50 lines of code. So I guess I can sort on this is lattice, new lattice pictures. They got exciting here. Here, we'll show you short lines of code. If I can go do that. Let me pull up JS viewer. This. So share. This has nothing to do with compilers, but you know, what the hell? I'm trying to write a tutorial. So here, of course, the font's too small and I can't get at my menus because Zoom is like busy hiding them from me. Options, here we go. Font, whatever, something giant. All right. So I don't care. All right. So maybe reasonable. So, there's nothing going on the server side yet, except he starts a server and then he gets source code from the browser, and then I ought to do a graph viz on that and hand something back, and then we'll go back and forth with the browser telling me that I'm going forwards or backwards in the graph viz animations and the server producing new animation pages on demand as needed. But now I need a WebSocket because I can't figure out how to do this on the JS side without a WebSocket. Um, So somewhere in here, he says, new WebSocket. Well, okay, as soon as you said WebSocket, you were screwed. If you said TCP, he laughs at you and says, no, that's a security hole. You can't do that, even if it's local, even if it's to yourself, even if the process that launched you and wants to talk to you. Can't do it. No. So you're fucking WebSocket. What's a WebSocket? Oh, geez. Okay, so launch the client. So I get a tab on the browser. Make a simple server socket. So this is WebSocket extend server socket. Accept on it. That's pretty obvious. Okay, now I have to do this crazy handshake thing. So go to the WebSocket and say read all your lines until you see WebSocket key and just chop out the key part and make a response that consists of this magic protocol that no one cares about, except you take the key that you're given and it's way on the right over here. You append it to this giant fixed string. You run it through a SHA-1 digest and you base64 encode and jam it all together. It's like this magic cookie that you read on the internet. Oh, come on, guys. Then you're finally down to you have a WebSocket you can talk, but it comes with these frames that are encoded and you have to decode them. So you read and you get some number of bytes back. Oops, some number of bytes back. And then you discover that the bytes are all plus 128. And of course, they're bytes, and Java's stupidly doing bytes stupid. So you have to strip the byte sign off with a 0xFF. Then you're looking for, hey, is it a fin tab with no extra things going on? It's all in this one message because all my messages are short. This is for breaking up long messages. Get a length out again. Giant messages. No, 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 no. I'm only sending short messages. I'm only getting short. I'm going to send giant ones. And then I go get the key. This is the encoding key. Then I decode you by applying every byte to the key with a XOR. And then I make a string, and now I can get a string back. And it took me, all day to sort out that I couldn't open a socket and I couldn't talk some other way, and there wasn't a built-in thing. And finally, mid-afternoon, I said, I have to do a WebSocket. Now, how do you fucking do a WebSocket? It took forever. Fine. And the put's a little easier because I just jam things out. Although, as soon as I do graph viz docs, I'm going to get more than 1.5. So I'm going to have a couple of write paths. Anyhow,
Hmm.
WebSocket. Why did I have to do this? Why couldn't I find this? This is a fucking, what, 50 lines? Let's find out. Wait a minute. Line 29. And no, my key, I'm all messed up from fonts here. Line 102, 29. So it's like 70 lines. If I add in the response for the fatter header in and out, I'm probably 100 lines. Where can I find this 100 lines on the internet? I don't understand. Who did not put this 100 lines of stupid open source-ish code on the internet? Fine.
Hmm.
So that's my bitch for the morning. That's what I wasted yesterday doing. And then the other bitch, not a bitch. This one was more fun. All right, I'm back here, Google, Zoom, something, not you, you. So this is the old lattice chart from chapter 2, which is just integers, top, bottom, integers, increased font sizes and made it say int because it gets more exciting in later chapters. Somewhere near the bottom here is a new chart. Okay, here's a different lattice. It's color coded. Holy crap, it's color coded. And it says int here in the middle again. And there's control like you'd expect. And here's tuples, but tuples got some structure now where they have a constant that says I'm a tuple, but then they have black types because it's recursively any type. So a tuple is a collection of any types. And they're a fixed size. And if you mix two different sizes of tuples, they fall to a broken tuple. You're not allowed to do that. But if you just take two tuples of the same size, then they meet together where you recursively do this whole chart meet on the insides of each one of these. So I thought that was a nicer way to present it. Of
Hmm.
course, I don't have a before and after. I think chapter 10 was the next one that got hit. And chapter 10 has control and X control. Oh, this probably should have been chapter 4 or 5 or 6 or something. Control X control show. And here's the ints, abbreviated a little bit. Here's tuples still there. And here is pointer structs in memory. What's going on here? Well, memory is easier. It just has alias numbers. Later, it picks up contents of memory as a black type object. Pointers are just null or not the null, and literally that is all they are. You're null or you're not, except you have a green struct. And that is recursively this struct here, who has fields, which are field names, and fixed sizes, so you can't have subclassing in this lattice. And then each of the other sides is either an int or a pointer, and it's recursively int or pointers, which pointers can point to structs, can point to things. So that's the new lattice uh, for chapter 10. And chapter 14, yeah. So chapter 14 picks up narrow ints and floats. So structs, well, you probably can't see that. I don't know how to, let me, that's probably better.
Yeah.
I can't make this go away on the left.
It's on the file when it says
Oh, that's right.
files.
Wait,
Yeah.
somewhere,
Up,
where,
up.
where do you, where do you
Wait.
find?
Yes. Yes.
Yeah,
Uh,
thank you. A little
hmm.
better. Grab the scroll bar, a little more control. Yeah, right. Okay,
Yeah.
so then we have floats, which are easy. A top float is a top float 32. I probably should do a top colon 32 in there,
Hmm.
which 0 is a sample float constant and all the other 32-bit constants, and then bottom floats and 64-bit bottom. Pi is not within the 32 bits because it's a 64-bit constant, and all the other 64-bit constants excluding 32-bit constants. So that's the last for floats. Ints picked up a min and a max. So the bottom version is all ints where max is max int and min is min int. Then there are ranges, and there's any number of ranges in here, and I'm just showing them as a single box. But it's anytime max is greater than min, you have a range. But any range can include another range uh, if they exceed max and min in either direction. And then here's a range from 0 to 1. It's Boolean, which comes from a constant 0 and 1. And then the top side is you flip min and max. So 1 to 0 backwards is the top Boolean, and so on and so on and so on. So that was the description presentation of the lattice as it gets to chapter 14. And I might have one more, and then I didn't get to the functional lattice, but it's a coming. I went here. I graph viz myself all day. 14. Yeah, I didn't do 18 lattice because I mean I started it and then I said, oh, graph viz thing. And the lattice for 18 is not there. So function lattice is not there, but it'll be coming. And it'll be sort of obvious. It'll be, arguments like you do tuples, arrow, a return, and I'll actually have a count of allowed functions because there's only a finite count of functions in any program. So they'll all just be given a function ID number. That'll show up in the lattice too. All right, that was me with lattices in simple.
So it seems that it's a pretty rich type system by now.
Yeah, that's the thing. I think that I don't know who gets there, but I hear people go either direction on a lattice. They mostly think it's trivial and they don't think anything about it.
Mm.
Or unless they're doing Hindley Milner, and then you got this crazy type thing going on.
Hmm.
But this is like a standard lattice presentation, except that I'm starting to show all the things you show up in the lattice. And they're really easy to add. The amount of code involved is smaller than the graph. Like the integers min and max, the delta between the prior thing, which I had a flag saying I have a constant, and then I had a long value for the constant. When I put min and max in, it's actually, it's no more code. But you get this, I can do ranges, I can do narrow ints. I'm showing bool, but I can do ints 0 to 8. Like the discussion here, I added bool is a type of the range 0 to 1, but unsigned byte is range 0 to 55, and signed byte is this range, and so on and so forth. So you can do all the byte ranges and everything in between with a handful of lines of code. And then it just sharpens your math everywhere you do anything. Any optimizations come along, they just sharpen by that amount. So the structs here don't allow subclassing, which would be some subset of fields. But if I do standard single inheritance subclassing, then some prefix, not just any subset, but a specifically prefix subset would inherit from a postfix or whatever larger suffix. And that would turn into, that's just another lattice element. So you can flow subtyping through here as well. And you get all the usual analyses. This is what C2 does for subtyping, and it's actually pretty robust. Gets a lot of generic type erasure rediscovered in C2 by just doing the lattice work here. All right.
Cool.
Hey, Bill. Um,
Hello.
hey, you got
Whoa, man,
John.
shit. That's a beautifully colorful diagram.
Mm.
So I missed the whole first part of that, but
Oh, this is a lattice for doing standard type analysis, flow analysis on a standard sort of C Java Fortran program.
yeah.
So there's 10 seconds to it. Well, I can't get this chart to hold steady with a small scroll. The yellow on the left is color coded now. It didn't used to be. So it's new diagrams. This is why I'm showing them off. New diagrams.
Yeah.
And the documentation. Yellow on the left, color coded control, and the top control is basically unreachable code, and the bottom control is reachable. It's pretty
All
easy.
right.
And then floats are these aqua, light blues. Top float, unknown float value, unknown 32-bit constants. Zero is a sample 32-bit constant. Pi is a sample 64-bit constant. And then the bottom, any 32s, any mix of 32s, and then bottom floats.
By sample, you mean just you didn't show them all in the diagram because that would make it
Yeah,
very wide.
because
Okay.
4 billion takes up
Yeah.
too much space. Yeah,
Okay.
exactly. And then integers are a little more fancified. So going from the bottom up, integers have a min and a max, so they support a range. So the bottom most guy Ooh, look at that.
Oops.
Oops, that didn't do what I wanted it to do. Oh, that didn't the back didn't work either. Um, max and then max greater than min is anybody where the max is greater than the min. And there's a huge count of these. There's 4 billion times 4 billion,
Yeah.
and they have the obvious relationship where they're in the lattice, above or below each other if they include.
Right.
And then here's a sample version where max is greater than min, and that's bool, 0 to 1. A range from 0 to 1 is bool. Zero is a sample constant, one's a sample constant. Then they have the inverted guys, which are the high side, the top versions you get when you do the sparse conditional constant propagation. You start everyone at top and you have them fall, you get up here. Anyhow, these are just switch min and max in the code, the implementation. So the actual implementation of this range analysis for integers is basically no more code than what I had before, which was conceptually easier to understand, which was top, bottom, and a constant. So you had a Boolean flag for I had a constant and a long that was the constant. But if I just switch out the bool for a min and a max, for the max, and the other one's the min, then I have two fields still, min and a max. But the actual logic involved is actually simpler. So it's no more code to do ranges. And then arbitrary ranges from integers means that bool is a range from 0 to 1, and U8 is a range from 0 to 55, and I8 is a range from, blah, 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 and you
Oh,
go
that's
on and on. You
interesting.
can do all ranges.
Huh. Okay.
So narrowed ints from 1632, whatever. So new in chapter 14, you get narrowed ints. I'm doing
Okay.
arrays, so you can do IO, and
Yeah.
you have an array of bytes. Well, what's the type of array of bytes? Well, it's a byte. Well, okay, so byte's a subset of short and car and whatever. You do all those things. So let's go back over here on the
That's
right.
interesting.
Tuple is an internal, it's not a user visible type, the pink thing tuple on the far right.
Yeah.
It is a type of things that are collections of values that are otherwise not very well related. And they're used in like control flow where I have two control instances coming off an if. An if has two branches. Is the left
Right.
branch alive? Is the right branch alive? Well, I get two instances of control. If I have a function call, the function call is going to produce out a control. I exit this function and a memory state and a return value. And if I'm Java, I'm going to throw more controls for exceptions. And if I'm doing aliasing in my memory, I have a bunch of memory edges out as well. So tuples contain lots of weird types. So the black type refers to the top and the bottom of the whole chart. It can be any one of these types in the entire graph. Although if you mix two tuples of different sizes, like a 2 type and a 3 type tuple, you just go to bottom, that's an error. They don't show up in broken user programs, they show up in broken compilers. If
Mhm.
you get this in your compiler, you should just assert that the compiler has an internal error. But within these two types, or these three types, field by field by field, they want to do this whole lattice operation, and that works and is pretty reasonable. Going left here,
Wait a
the
second. Wait a
dark.
second. That one I didn't quite follow. This is a what are your tuples again? First of all, the top and the bottom. Which one was reachable? Which one was unreachable?
Okay,
The
control is unreachable. That's yellow on the far left.
oh, okay.
Tuple is a collection of any black type. So type at the top, type at the bottom,
Right.
any type. So tuple is two of these types recursively. But
Oh, I
tuple
see.
one,
So in other words, those are the bounds. It's either it could be any type.
yes,
Yeah. Okay.
yes, anything in that range.
I see.
Typically, they are fixed by how they're being used in the compiler. Typically, they represent control, memory, and value.
Okay.
There's a couple places, like I said, on an if or a switch, you have multiple targets. They have multiple controls. The types are all instances of the yellow control, which could be reachable or not reachable. Um,
Okay.
right. They show up in a couple places. And you want them because you just want a collection of types of these black types, which are this whole thing, that then follow the lattice. And when you do meet operations, like the definition of tuple says, if you have unrelated, if your edge counts are the same, you're good. And if your edge counts are bad, you give it up. You have a bad tuple. But if your edge counts are the same,
Okay.
you just recursively call meet on each of the types internally. So it's a standard. The
Hmm.
meet is just recursive for all type fields within the tuple, and there's generally only two or three.
Yeah.
Call meet recursively, and that's the meet of two tuples. Yeah, fine. Um, okay, well, let's go left one. Memory here is for aliasing. It's the equivalence class aliasing. So these are alias numbers.
Hmm.
I'm not actually showing here, but at some point you will probably allow multiples alias numbers, so pointers from different alias domains could mix. Um, Actually, yeah, not maybe not in simple. AA is doing that for sure, and that just means that you have some count of things that where your aliasing comes from. In simple, the aliasing comes from uniquely named structure fields. So any one of these blue balls that has an alias number, has a memory state, refers to exactly one field out of these structs here,
Yeah.
but one field class of all those instances of those structs. So every person struct has a name, and every one of the person.names are all in one alias class, and they
Hmm.
shall not mix up with pet names.
Right.
Okay. So then we have pointers and structs. Pointer is the little green here, and then the
Hmm.
light green for struct. That's a recursive pointer struct. These structs are typically or only a Boolean flag, and it's either you have allow a null or you do not.
Hmm. Okay.
But when you point to something, you point to a struct, and the struct can be high and it can be low. And right now, it's simple no subclassing. So you're either a one, two in however many field struct,
Yeah.
and then within those instances of those structs, the fields also have to match. And if any of those fail, you fall to bottom struct. But if everything matches, that's the kind of struct you are. And then you have field names,
This is
and
just you're not. It's not nominal. You're just looking at the fields, and if they match, it's structural, essentially
it's structural. Yeah,
matching.
yeah.
Okay.
Like if I wanted nominal, I have to have a different. I have to have
Hmm.
a different type analysis
Okay.
to allow it. Like the lattice will handle nominal, but I'm sorry, the implementation of the code generated is not as trivial. So if you're doing nominal and you do function calls, you get an interface lookup, an
Hmm.
interface call, which has a different lookup strategy than a virtual call.
Right.
You do
Right.
nominal on struct fields, you can do field lookups. Well, the fields don't get aligned necessarily. So if I have the field name and it's on the first field in this middle guy,
Hmm.
here I clicked it, thou shalt not click. Um, the first
Hmm.
guy's name, and over here and the third three column guy, the third guy's got a name. Well, the offset's different. Here the offset's 0 from start to struct. Here the offset's who knows, 27
Right.
from start to struct.
Right. Yeah.
So you do a nominal call, you have to have a different strategy doing field access.
Well, it's like nominal, like in Java, for example, there's class extension and interface implementation. And interface
Yeah.
implementation is what you're just describing. But class extension has got a name, but it still keeps it
Oh
in the
yeah.
same
So
order, you
so
know.
I'm doing named here. The structs have to have a name, but if I tossed the name away, literally had less code, I would go straight to what you just described. Two structs with identical fields and identical order, I would allow.
Okay.
And
Hmm.
that's a constraint that I've artificially added in. The type system doesn't care. It would literally be a simpler implementation to allow two structs with the same field layouts. And that's it. As soon as you do
Okay.
subclassing, that's what you get. And that's the prefix fields are aligned. And then, you do some
Are you
prefixing.
going to do subclassing in your simple example?
I don't know. Not yet. It could
Okay.
happen. I mean, I'm totally patterning this after C++ and Java, basically is the internal implementation.
Yeah.
So it will naturally flow into like no extra work will be done to flow it into subclassing. I do functions. I'm going to arrange my functions that they will be convenient to virtual call. That's chapter 18.
Okay.
And then, that's one step closer to having subclassing. Yeah.
So how far are you going to go? I just started, by the way. I did chapter one and I converted it to Scala little bit a little
Oh,
so I could understand each piece.
well,
And then
nice.
I'm in the middle of two, but then Thanksgiving came along and I didn't have time to finish that. But
Well, there
so
you
I'm way
go.
behind. But I actually think this is perfect for me, because I've never done back end kind of stuff, and so this is a great way for me to figure out. I keep up with the conversation with you guys. I can kind of understand what you're talking about,
Sure. Well, if you
hopefully, as I
get,
go
far
through.
enough
So
along, you think you're going to be consistent at it. You know, add yourself to the repo. Yeah.
Yeah, I was going to make a pull request because I got a bug, but uh, I will do that at least.
No, where'd my repos go? Yeah, here we have 5 repos. So I think the Go one has stalled.
Yeah.
Garden is off. Rust was 2 different guys, I think. I'm not sure which one Tommy's doing, but Robert's waiting for me to get function calls in
Actually,
for code
I had
change.
a question for the Rust guys, which is how do you do the doubly linked list? Like
Oh, I
your
don't do
graph
doubly linked
is
lists. So there you
well,
go.
no, your graph has pointers going in both directions.
Yeah,
So
well, I
how do they
implemented
do
it.
the
Oh, you
how do
should
they do the
implement it
ownership?
the way I implement it
Hmm.
Oh,
because it's stupidly easy. And then I'm going to
well,
have all kinds of hacky manipulations on it. And,
yeah.
there's no,
Yeah, in Scala you can. That's what I did. But I'm saying in Rust, then they got the problem of who
oh,
owns that, How did
yes.
they do it,
In
I see what
Rust,
you're saying. I was going to
Because that's
show.
a pain in
No, the
Rust.
Rust guys have all gone to what to me look like horrific things where they have node indices into arrays of nodes, which maybe it's the only way to do it.
yeah, it's actually like all kinds of linked data structures are pretty simple. You just do indices. That's it.
Just do
That solves
DC.
literally every
Oh,
indices. Yeah,
indices. Yes.
yeah.
Okay.
It
Right.
Yeah,
solves
so
every
it's
problem.
it's a separate. Yeah, that's what I was thinking is they would what's that called? Array? What is that called? I read that about Rust, like how you deal. One way to deal with it is you make an array of indexes into basically use a data structure that's
Yeah.
extra. It just costs extra time probably to run, but then you don't have the cycle.
No, you do an array of nodes directly, and then you have indices into those nodes,
Right. Yeah.
and you
Yep.
move collections of indices about. Yeah. And then
Yeah.
the
Okay.
lifetime management is you toss the whole array away,
And
which
that's what they
honestly is
did.
what C2 does. C2 puts things in a giant ass arena, might as well be a Rust array of nodes. And then he does
Yeah.
phase flipping at different phases where he copies only the live shit from the old arena to the new one, and he blows the old one away, which he blows away by just resetting because he does a double buffer. He moves back and forth between the same 2 arenas. But yeah, that
Okay.
makes sense. It just seems, geez.
Well, it's interesting. I just was curious how they did it and how that affects
I
performance
mean, I can go
and
drag up. I watched the discussions go through on the here's the Rust one on the Discord channel, and they were like, this is so ugly. What am I doing here? So okay, fine. Which one should I go through here?
yeah.
Yeah, right. Arena.
I couldn't. I tried to look at their code. I'm like, I'll ask because I don't. I was just curious, like in general, how often they hit that problem because it seems like a cycle in a graph is not that unusual
Right.
to
Oh, it's
come up
you have a
with, and it's
loop. You
it's
got a
it's
cycle. Right.
very
I mean, I'm
uh
seeing unsafe left and right, and I'm seeing
oh, you're saying
arena,
unsafe.
the arena
Oh,
name
okay,
everywhere. So I suspect it's just exactly what you're saying.
okay.
Yeah, yeah, yeah. Some kind of
Hmm.
arena. This is all the arena management for getting arenas of whatever sizes. Fine. These are tests on arenas, maybe. I don't
I
know what I'm doing
see.
here. Fine.
Okay.
Yeah.
Anyway, anyway, I like this. I like this. Once you
oh,
pointed me to the
I
repo, I
was
really quite like this book or whatever you want to call it. It's nice. This repo is nice. This project.
this project good. All right, cat. I am about to be cat attacked. I don't know. We're mostly done here. Pointer to struct and struct. Oh, the interesting thing of structs is that the type is limited to ints and pointers, although in this chart it needs to be ints or floats. And I didn't want to make it even fatter, so it doesn't say int and float, but scalar values. Fields have scalar values. They don't have memory. Tuple has the black type, can be memory, and in fact it commonly is. Struct fields cannot be memory. They can be ints, floats, pointers, but not structs. If I get to inline structs, then you would have a struct inside, which could happen also.
What do you mean by memory? You mean allocate on the heap or something, or a pointer?
Memory is a chunk of memory. It is not a pointer to a chunk of memory. It's
Oh,
a chunk of memory.
okay. Hey, I had a heuristic question. Like over there on your light blue ones, or was it well, anyway, the ones we had ranges.
Yeah,
How
okay.
often, like, what would you say, can the compiler figure out uh, what the range is such that you can
Oh,
make optimizations,
Yeah, right.
versus I have no
So,
idea. Like, is it like
so
90% of the time you can figure it out, or 10%
yeah,
of the time you
right.
can figure it out?
So if you are writing arrays with reduced sizes, say array byte, because you're doing networking, always you get them all the time.
Okay.
Uh, so where's my narrow types? Oh, arrays are next chapter. Let me. I don't know. It probably doesn't help to look at arrays. Oh no, here. What is this? Pre-post? Oh, it is arrays. Oh, there's some errors on arrays, parsing arrays. Here's an array of ints. But anytime you do an array math, he turns around. Here I'm talking about how to do the scaling and arithmetic, how to do implementation of things, how to do layout math. There's a layout comes in here as well. Optimizations for array math. You're not seeing it here. Okay, so suppose I'm doing anytime I'm loading up bytes and converting them to Java cars, or I am signed or unsigned extending, or I'm masking them. People do bit twiddly stuff in C all the time. All those show up directly in the ranges. Uh, Go to the latest available guy source main node. Let's look at, hey, shift arithmetic right. Oh, shift right is probably a little easier. Compute call. Get the basic types. If they're high, just give it up. You got some integers. If one of them's a zero, then the other one's a shift count wiped you out or something. Otherwise, I do this. And I got exactly that value. That didn't give me any and masking. I was hoping for and masking. I guess you don't get it out of shift. Oh, I have an and node. Here, type integer make mask. What is mask? Well, mask is something. Well, I'm not doing anything really clever here. Oh, it's because it's an and mask. You get it all the time. It shows up as, well, like this, where I get and masks and I wipe you out. Um, in C2, you showed up in fixed count for loops, which commonly show up when you're doing, say, byte reversal, and you have four, 0 to 4, 0 to 3, you go reverse. It shows up in fixed count arrays, any fixed count size loops. Shows up in enums, where you can drop instances in and out. It's not as good as a standard bit vector for an enum, but it does show up there as well. And the code involved is almost free. It's like stupidly little code in the type integer um, math section. Here's a bunch of sample integers, tests on construction, printing, more pretty printing, get a log size. Here's a mask guy who does a thing. Okay, the scroll's too aggressive. Um, if I'm trying to come up with a bit mask, I believe we're forcing zeros. I just do a little bit of math to get a mask into a range. The meat call is ludicrous. It's this one line. I mean, it's min of the min, max of the maxes. The dual, swap min and max. So trivial. So the amount of code involved from getting the lattice to function, I mean, the inner type integers in the lattice function is really minimal, and you get a decent set of things out of it. The main one is going to be you have sub-integer ranges in arrays. I have arrays of ints. I have arrays of shorts. I do long math or I load them into an int. Now they look like int typed, but I know I just loaded a byte, so I know I've got a range of whatever. And then I and mask it, and I know that, oh, it's an and mask on a signed byte. Well, then it's going to be an unsigned byte. And then as soon as I get into code gen size, I'll say loaded an unsigned byte instead of doing a load and an and mask. So it turns out has a direct impact on your code gen. And that kind of thing is like really common. So I claim it doesn't seem to be a huge lot more productive than having just a constant, um, except in and around, I mean, not a constant, but a set of known ranges, a 1 byte, 2 byte, 4 byte, 8 byte range. This is not a whole lot more actually finding stuff. It does. It's not a whole lot more though. But it's simpler. It's vastly simpler to implement. There's like no code. I'm looking at mask, it has some interesting code, but the meat is this one line. I can't make it any simpler. So if you're going to have an implementation that's just as productive as saying, I know that you're a 1 byte, 4 byte, 2 byte, 3 byte, whatever byte thing, you must do ranges. You get the same thing and a little bit more in different directions. And if I need to do enums, then I need to actually have like a bit vector set in here where I have a set of known bits and a set of unknown bits. Here, my unknown bits are always the high order bits are either all zeros or all ones. That's what I can limit it to on the range. And in a bit vector, I'll have some more control over that. And I can mix ranges and bit vectors both. That would make this a little more complicated, but it would let me pick up the enum thing. Everything else in here is just like accessors to help or pretty printing or the like. Like, this one says, look, if your range is one of these fixed known ranges, use this fun string. Otherwise, print yourself as a range. So,
Cool.
yeah,
Thanks.
yeah. I don't have any other things going on here. I've started down function calls, but I've only started and I quit. I'll probably dork around. Well, this next week, holiday week, I may do AA and I may do simple. I was trying to do animation on simple, and I fought WebSockets horrifically, and now I'm ready to go do animation on simple. But if I go into types here, I'm going to do the functions on the types, which I didn't put that in here. When am I? Oh, I haven't pushed my lattice. Yeah, I didn't push the lattice with functions because it's not done. So functions will be let's roll up a little bit here. Function types. You have to start with function types. Function types will be arguments, arrow returns. That's the syntax for function type. Crucially for me, having an open curly unambiguously allows me to say I'm starting to parse a function type. So that's my one character look ahead, recursive descent, hand rolled parser. Functions look like types, except they get filled in. They have argument names, not just argument types. And they have a body, which I'll make the return optional. And so if you just end in an expression, that's the value. You can declare them because they are anonymous. This is an anonymous function. First class anonymous functions are no longer surprising to folks. But because they're anonymous, you just assign them like a standard variable. So here's your variable name, distance. Here's this type. Well, float, float, arrow, float. Here's the expression, which is a function expression for that type. But there's no named functions. Functions are always anonymous, but you assign them to a variable. The variable is the function name if you like. You can obviously, do type inference using just that lattice you just saw. That'll type inference this just fine. I'm going to have a standard function called syntax. I have a shortcut that says if you have no arguments, you don't need the arrow. So here is a just5 function, which has an argument. And I failed in the docs to have a new line here. This should be the next line down, where just5 could also be declared without the arrow. And you just call it with no arguments, and you get a 5 back.
Would it
So the
return
curly
5?
braces.
That's 3 different people.
Oh, go ahead.
Taylor first.
Go ahead, Bill.
Well, I was just saying the curly braces signify that it's a function, not just 5.
Yeah.
That's correct. This says I'm a function. Here's the body of the function.
How many times would you evaluate it? Every time you just 5, or it will constant fold to a constant?
Well, no, this is the semantics. Constant
Okay.
folding is an optimization, right?
Yes, but how? Well, if you don't do optimizations, then every time to just 5 would return a new 5.
If I make a C program and I compile it -0 and -g, he'll make a call to a just5 function who will load 5 in a register and return it every time.
Okay.
So identical in that sense. Now, because it's simple, I'm going to say I'm going to do debug info the way I do it in Java with the save point. I'm not there yet. It should happen. In fact, it probably happens when I do functions because I'm going to get it for free elsewhere. Uh, but then this will be a function call, and then there's an optimization on the function call, which probably doesn't happen in this chapter. It happens in an optimization related chapter.
Yes.
That would inline. This is an obvious candidate for inlining. We'd inline and disappear. Yeah, fine. All right, somebody
What do
else.
you do for blocks? If you're using curly braces like this, how do I just make a block of code like in C? I can just put something in curly braces and it means block.
Oh, I'll have to go make sure I'm actually ambiguous. I know I've got this going in AA, so I'm just going to use the same strategy. Um, Blocks don't do, okay. So there are, that's a, no, it's not. Okay. There are no blocks. There are blocks and there's no blocks in AA. You get that effect a different way. In simple, there are blocks, but I think I can tell them apart unambiguously, but I'll have to go look. That's a good point. That would be an if block where I'm optional. I don't have the, I mean, I can look, go look at the parser. It's going to say basically, he's going to walk through and say, I found a place where I could have a block or a statement. So he starts with a block for the whole program. That's easy. And parse block says, I already ate the comment here. Oh, it doesn't parse the opening closing paren because of context. God, zooming up and down here. And where's my scroll bar? I lost myself. There's this one. The other place, here's the implementation. Let me scroll slower here if I can figure it out. Implementation just says, push a scope while I don't peek a close curly and I don't hit the end of the program, and your error there. And then you use a bunch of statements. Okay, that's pretty obvious. But now go find here. Here's where you would be ambiguous, perhaps. Is this the start of a block, or is it the start of a parse declaration statement, which will totally turn into an expression? So an expression assigned, or it's just an expression. So turns into an expression. It could be a function expression. So I think I have to be careful there. But that won't work on an if because I don't have value types. I think it's unambiguous still. So I haven't got there. I'll obviously make it unambiguous, however that's done. I think it's unambiguous at the moment. All right. I'm fighting a cold as part of my being slow this morning, sleeping it off. What else was doing in here? Well, that's basically the question was like, what do I do? So I think it's unambiguous. Let's go back out to my functions here. Kind of hit return and get back to it. Source, one more. README. Yeah, just fine. I think this is unambiguous. So then I went into and comments to myself. So none of this is like official documentation. Are if you make a function inside of a struct and it's actually declared final, I'll probably have to make that requirement. Then you could have a hidden self argument, which basically makes you a member function, a method, without any change in syntax and without any change in implementation of the function either. It's just how you're going to call it. So here is a string struct, a potential possible string in simple. It has an array of unsigned bytes for cars. The leading underscore says it's private. The fact that it doesn't have a question mark means it's not nullable. And since I didn't say otherwise, it's going to be final, has to be initialized in the constructor. So it's a same as a Java string. It's a static private final array of cars. Length is a function. It's a value, so that's final. It's not a var, it's a val. And it returns the length of the array of cars. At gives me a lookup. Append takes a nullable string and says, if you're appending a null to a string, just give the string itself. And otherwise, I do a manual array copy because I don't have an array copy primitive and simple. So I just make a new array the size of the old array. I do a for loop, and I just copy the characters, and I copy the other side of the characters. So this is, make a new array, make a new
What's the
string.
pound sign at the end of underscore cars? What's that pound
That's
sign?
an
Is it part of
operator
the?
that says, give me the length of an array.
Okay.
It's an operator, just like plus postfix plus plus, or a prefix
That's kind
minus or
of
prefix
interesting. Did you just
plus.
make that? Did you invent that one? I haven't
Yeah,
seen that before.
yeah, I just invented that one.
Okay.
Been using it on AA for a little while. I like how it looks, so you could argue against me. Um, Fine. I'm willing to hear our discussions. So here's some strings. Now some parser needs some parser sugar to turn a quoted string into a this class string. So this string becomes an implementation that's known to the library and it's known to the parser, so you can't replace it at will. You might be able to extend it someday, but you would then call like append, hello, Cliff. And then there's a little syntax going on here for the method calls, and that is when you say greet dot append, okay, dot append is a field lookup. That's a dot append is always a field lookup. So here's the field, right here is the field, does a lookup. That returns a function. Okay, as soon as I say struct dot append and I get a function type back, I'm going to add a syntax that says bind it, curry it to the self argument. So I'll get a function back that is this function where the string, the hidden this that's not shown here, the self, is bound to this. Now, having at this point in the parser, so see here, but not parsed any function call, I have a thing which is a pre-bound curried function, which takes one more argument, a string argument. And I can do anything I want with it. I can sign it, I can pass it, I can hand it out to other people. I don't care. It always refers to the hello string. And then I call that function with an argument, and oh, look, I get my appended string.
Could you make the inverse? Make the function append outside of the struct and says that it has to take the self value, which is implementation of a struct?
Yeah, so I wrote it in here, but I could write a version of append, which is basically a static function outside any
Yes.
struct, and it takes two strings and appends one to the other.
Mm.
And I might call that plus, because it's string plus string, and it would be outside both strings, and it would take two string arguments and append them.
Mm.
So I think
have a
the innovation
question.
I'm doing here, oh, here's our new line missing. I can call var at hello, which is greet.at, which will give me a function which takes an index and returns me characters from the hello string. And at cliff of 0 would turn me the C lookup, and at hello of 0 without having the hello string, but the at hello function. Oh, this is incorrect syntax. This should be open close parens. So,
Adrian, did you have a question?
Yeah, I guess it resolved itself. So I was wondering, like greet.append, I guess you can bind it to a variable.
Mhm.
You say it's a curried function. Like
yeah.
what kind of what type is it?
What's the type of the function where the first argument's been filled in? It becomes essentially a fat function pointer.
A fat function. Okay, all right.
The implementation
That's
is as if
what I
a
was
fat
wondering.
function pointer.
Okay, yeah, that was what I was wondering about.
Since I have strongly typed functions as instances of functions at the moment, I probably don't need any other bits than the greet structure. And I'll know at any variable that it is the append variant of this greet structure, of this string.
But do
If
you
I
have
start,
such a do you have function pointer types or
yeah,
something like?
that's this whole thing. Here is the textual description, but the lattice isn't put together. So the lattice will be sort of as you'd expect here, a collection of argument types and return type, just like you do for structs as a collection of fields. And that'll be a function typed thing, and it will have also a list of function identifiers, because every function turns into a unique piece of code, and you're just going to number them 1, 2, 3, 4, 5, 6, 7, all the different unique functions. You just number them, give them a number in the thing, and you put them in the type hierarchy as 1, 2, 3, 4, 5. You get a bit vector of them, a collection of them. Most of the time when you do things with functions, uh, you only ever refer to a single instances of function code, like the append code for string.append. And so I'll know, I won't even need a fat function pointer. I'll just say, which structure was it? It was the Greek structure. Okay. But I know you're calling append in this variable. So to do that, I need to go to an editable, oh, the docs, blah, 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 obviously. What the hell we're doing here? Right. Is this readable? Do we need to make this larger?
It's fine.
It's fine. I know people hate it, so I'm doing this anyhow. And then I'm going to die. My throat is so bad. Yeah, so struct string is I should cut and paste and get, but I'll just do a little bit in here anyhow. Bar append is equal to string question mark string arrow blah blah blah. Okay, so I have something like that, and then I said, well, I have a string greet equals a new string of whatever, but I'm going to take a partial shortcut here. Okay. Then bar foo is 3 dot. Okay. Like that. Is that what you're asking?
So yeah. So foo's type can't be the type of just append, right? Like it needs to have a different type because it has a different size, right?
Okay.
Like it
So,
needs
so missing here is this as a hidden thing.
okay. Yeah, sure.
And the type of this is string question mark string. Or no, string. Without the self. It's been curried.
Yeah, but I mean the type. I mean a type has a type size, like a size, right?
I'm sorry,
Uh,
the type has a size?
like any given type has a well-defined size, right? Like one
Uh,
single or not.
I'm not sure what you mean by size here. Like,
Bytes in memory.
okay, no, okay, you're mixing two concepts. One is there's an implementation, and one is a mathematical entity which has no physical size. It's just math. So there's an implementation of what I do with foo. That's when I said fat pointer or fat function pointer. So we could argue what implementation do I want to use here? Right? So let me should do another function here. Var dist is equal x, y, arrow, squirt of x times x plus y times y. Okay. What is the size in memory if I have to put dist in memory? What is the size of dist in memory? Well, the obvious implementation is it's a function pointer. And that's are usually the same size as your standard pointer size, which depends on your implementation. Well, let's call it 4 bytes. So this is probably a 4-byte function pointer. But different implementations could have 8 bytes here or do something else. If dist is only ever called but never passed around as a first class object, it never gets manifested in memory as a function pointer. It's just used in call sites and places. So somewhere in the world, I say print dist of 2 comma 3. Okay, in this implementation here, I'll never put dist in memory. I'll just call dist as a function. And the x86 implementation of that will be some x86 call op to some address of dist, whatever hell that is, where I've already preloaded, rax is 2 and rbx is 3 or whatever your calling convention is. But there'll be no function pointer for dist, unless you want to consider the constant bits in the call opcode to be the function pointer if you like. I don't know. Meanwhile, foo is a different story. Right? This is different because it's a fat function pointer. It has an argument pre-curried to it. Couple implementation strategies. One implementation strategy, the generic one, is I actually make a new function which loads the constant value for greet as the first argument, and then he calls the standard append. A trampoline, if you like. I could make a trampoline here. Or I could claim that in the case of foo, as an optimization, there's no other way to get anything but an append here. So this really wants to be it's typed as the append function. Well, what's the append function? It's this, but I'm going to add on to some extra syntax here in my comments. That would be append. This is only the append function in this situation here. Having known that it's only the append function as part of the type, and maybe I'll put some fun things here, like a pound sign is a syntax hint that this is the append function. But I don't know what the this is. So somewhere else in the world, I've said, oh, print, random of foo and some string I'm going to pin. I'm sorry. I'm not doing this the way I want to. Like this. So under this model, I pick between two different guys. They're both of the append type. So the result of this trinary is a typed function pointer, which takes a string, but it's also typed as the append function. So the implementation would be, I just need one of the two structs. I need a pointer to a cliff or a pointer to a greet. That's the actual runtime implementation. Then he says, since I know it's an append, I'm going to call the append, call 0x append, where I'm going to pass in the this pointer, which I got from the trinary, and the other argument, the comma, elsewhere, right? So somewhere in the world, the code generator comes along and says, call 0x append, that's an x86 call op. That append is a compile time constant. And rax is, whatever, it's greet, pointer to greet. I'll be a little nicer. It's the pointer to greet, and RBX is the pointer to cliff.
Okay, so then I have a question. So what about so would let's say like a bar, I don't know, something like this, that has the type like this, not the append function, but just this
Right.
part, like
Yeah.
takes a
The
string.
obvious next question is what happens when you mix other things? Then the
Right.
implementation has to do something different. Now you need a generic. So the type system, as I described, needs as a generic best case scenario or worst case scenario. It needs a fat function pointer, which needs the first argument, which either greet or cliff or hello or whatever it's going to be, and it needs a second argument, which is which function it is. And the set of functions involved is generally pretty small, so there's some amount of small count of bits to uniquely identify which function you're referring to. But the obvious implementation now is it's a pair of values in registers or a pair of values in memory, or it's a 64-bit value of which 32 bits is for the function. And God help us if you have more than 4 gigabytes of functions, more than 4 billion functions, not even code space, but functions. And then 4 bits for, the pointer to the greet or hello or whatever. So it becomes a 64-bit value. So this is the correct. Let's see if we can make a little prettier example here. But yes, this is a known thing, and I was showing you the obvious case. You're asking me, how do I represent it? And the answer is a 64-bit value. What are we doing here? I want a function. Yeah, here we go.
I guess the implementation that makes sense to me. My question is just, would it have then like would such a fat function pointer have a different type than a pure function?
I'm sorry. The fat guy has a type. But here's a calculator, implementation being worked along, and somebody wants to come along and say, what is the type if I manage to pre-query myself? I don't know that this syntax makes sense here, but let's be a little more meaningful. Both of these guys are typed as int to int.
Is this hashtag add or hashtag mul? Is that like part of the type?
Yes, it's part of the type. It
Okay,
is.
so you can't mix up that like without.
Sure, I can. Well, that's the whole point, of course.
Okay.
Well, let's put in a bar.
Okay, I see. So you make it easy for the user of the language, but then you're gonna have a bit of work to do on the implementation to make sure that you generate like trampolines and like all the magic of.
Right, right. The goal here is the user can use these just like
That's
regular
cool.
functions, but I'll make the implementation deal.
Yeah, that's very nice because so for instance in Rust, if you have so you do have like this thing where you have a this method syntax as a syntax sugar for function calls where you pass in this thing as a first argument, but it turns out that you can't actually pass um, like these pre-curried like these curried functions into closures because they just like Rust doesn't accept it, and they don't want to do this kind of dirty work. They consider like only like they don't want to mix up or like hide
Hmm.
this stuff. But I think actually think it's quite nice that you can like just treat these pre-curried functions as normal functions, pass them around, and let the compiler handle it. It's quite nice.
Yeah. So ints are kind of problematic because as soon as I say longs or 64 byte values or something, I can't. I need to do some. I actually need a trampoline. I was designing this for actual structures here, um, where this first argument is the hidden self. Uh, uh, because I knew that the hidden self argument is always of size 4, and therefore coupled with the set of allowed which functions you are is only 4 more bytes at max. So I can fit it in 8 bytes and be happy. So the int case is a little weird because I would actually probably have to make a trampoline. And the implementation would just make a trampoline and be done. So if you curry the add guy, probably actually heap allocate the trampoline. Life goes on.
Cool. Thanks.
Yeah. All right. Anything else? What else? With a new topic.
I had one interesting thing that I stumbled upon. It's single pass compiler related, but I kind of think it's funny. You can actually keep your desktop shared, and then I
Oh.
can write in the docs.
Ah, go for it.
It's pretty simple. It's so basically I had this idea of having one keyword introduce different types of loops. So I had so these were infinite loops. These were do while loops.
I hate do while.
Yeah, I know. I love them, but yeah, of course. So full expression. This is a while loop, and then
Hmm.
you have this is an iterator-based loop.
Mm-hmm.
So the nice thing is on a syntactical level, like if you're just parsing something, they're super easy to disambiguate because of this let. So the thing is like if I have a for and then expression and then a let, it means definitely it's an iterator-based loop.
Mm-hmm.
And if it lacks this let, then it means it's a while loop.
Mm-hmm.
So I get this one keyword and I make for loops from it. And I thought that's nice. And then I started doing like proper code gen, and then I realized that actually, uh, before I parse an expression, I need to know if I'm already inside of the loop header. And this is quite ugly. So the thing is,
Can't you
this
just
this this
stall CodeGen until you?
yeah. I mean, exactly. So I thought of multiple different ways. I kind of reorganized my code, and it just ends up being super ugly. I always have to kind of keep some state or like either delay stuff and then replay code gen in a certain way, or I don't know, just disable certain things with flags or speculatively compile like a iterator based loop and then fall back to yeah that stuff. But yeah, it's pretty interesting because this is kind of so I was always thinking as long as I make sure that on a AST based level, I'm like
You're not making an
unambiguous.
AST though, right?
Yeah, I'm not making an AST, but I thought just like if I make the grammar kind of this
Oh,
like unambiguous, then it
uh-huh.
won't cause any problems down the road. But it turns out in this particular case, I need to know very early on if it's part of the loop header or not, the expression. So yeah, that then I decided, okay, I turn this into each keyword, and
Yeah. Yeah, okay.
yeah, so that's kind of like a funny. This is just another thing where the
Well, that's
compile
because you're
implementation.
when you say one pass, you really mean it. And
Yeah,
so when you parse like bool expr or iter expr, you want to generate the code for that at the time you're parsing it, but you don't know
right.
until you see the let keyword which flavor you have.
Right. And the thing is, like, I thought I had a bit more leeway because in my case, I'm actually doing kind of a hybrid like approach. So I'm generating IR in one pass.
Yeah.
And then after I generated the IR for a function, then I do register allocation and lowering for that function. And I go function by function. So I do have like I do have some opportunities for optimizations and doing things out of order, like knowing whether or not something is a tail call or like how many function calls I have, like before I do all the later cogent stuff. But yeah, just for some things, I have to go the Pascal way, I guess, and yeah, be a bit more explicit earlier in the syntax.
So the simple parser for loops has this similar problem. The parser sees a for loop with an iter test next and a body, but the next code goes after the body when submitted. So the
Mm.
parser actually skips over the next code. As you said about the reparse or recogen, but for me, I skip over the next code doing a balanced paren search, emit and for the iter, I slap out iter code. And for the test, I put a while header and slap out the test code. And this place is slap out code. I'm making IR. I'm not making actual x86, but I'm making IR. Then I come to the next code and I skip it, but mark where it is using a balanced search. And then when I find body, I emit the body code. And then I go back and I reparse the next code, but now parsing it for real and emit it. So I did do exactly what you didn't want to do, which was go back and redo.
Jesus, really?
Yeah, yeah, it sucked. I hated it.
Oh,
I'll show you the code. It's just like,
I would love to see that. Yeah, I would love to see that. That sounds horrible.
yeah, and I'm all happy to have suggestions on a better answer, right?
I don't blame you. I mean, if you want to do it, then I guess you have to.
So parse for says, where to go? This is the shared, it's parse looping. Open my paren and make sure I'm not stupid. Go to parse looping. Okay, parse looping. Make a loop header.
Wait, can you share
It's
your
not
code?
sure. It's
You're not
not.
sharing.
Shit. All right. I am gonna die for bad throat here in a minute. All right. So there's some setup code here in parse for and a comment about what it looks like. And then for and while share this common piece. Okay, fine, they do. And I'm up here, and the init code got pushed already by the by this guy. The for loop does his init just right up front. Until I find a semicolon or an empty semicolon, parse a declaration statement. Anything you want in a declaration statement goes in the init code. Fine. And then I'm in the for loop. I put the while headers in. I set myself up. I put the if test. Oh, I'm doing for. Next position equals -1. Next n equals -1. Skip the next expression and parse it later. Grab the current parser state, which is just a pointer into the code space in the code string. Skip the assignment or skip a balanced next expression. Capture the end. Know that you have to have a closed curly. Now I'm doing the body. Do body things. I'm going to ignore. Here I am back in the same code. If I'm doing a for, grab the old position and assign it into the parser. Force your state back and return the old state, which was after the body. So I've set the parser to the next position. This is literally just an index variable. It says under X is the index pointer, is next pause and return the old under X. Okay. Parse an assignment, that's the next code. Then confirm that I got to exactly to the same spot. This is just a fucking assert. And then reset the parser back after the body. So it's this is the amount of code. It's not a whole lot of code, but it's just sort of obnoxiously mentally. Let me see if I get on the
Okay.
same screen at once. I can't quite.
Okay, it's not actually not that bad. I guess I don't have a function for skipping an expression. Like
Well,
like
that was, let's go look at skip assign here.
unfortunately the way like in all my parsing functions I do code and everything's interleaved. I guess I have some flags for like that code, but
Right. You'd have to. Wow. Well, here's Derek. I'm about ready to bail on you, Derek, because my throat's dying. So, hey, Derek. So yeah, the parser says, this is hit end of max values end of file. It's an error case. I don't have a test case for it, but if you have a for loop that's truncated in the middle of the next code, I'll hit this instead of that. He should throw in a different kind of error, but he just counts parens. And he doesn't need to count anything else because I don't have any like quoted strings or anything. The next car handles skipping comments and white space and shit. So that's it.
so this is just it specifically for loops or
Yeah, the only caller of this is the for loop skipper. Yep.
okay. All right. Yeah, no, makes sense. That's kind of it's actually not that bad. Yeah.
Yeah, it mentally it sucks because it breaks your entire model of how you deal with parsing in one pass. For me, one pass is a lot simpler. I do IR gen, not x86 gen, but actually you should be able to do this. This
Yeah,
is
I
no
mean we do
gen. You have to write your own, you have to write another Lexer path. That's what you have to do. Like next X car has been around, and the X means skip white space. So you'd have to have another Lexer pass because you're doing cogen mixed in here. But you should have, do you have a Lexer, do you have a Lexer part?
well, yeah, I have a Lexer. I don't do it in a separate pass. I mean, I do have skip white space functions and stuff. I
No,
mean,
well,
I
not really
actually think,
separate pass. This is all interleaved
yeah.
IR with parsing. I mean, you have to do some semantic analysis.
I mean, actually, I think we're doing something very similar. I mean, you're basically also generating IR in one pass, right?
Right, right.
So I guess like there's quite a lot of similarity. It's just that after I'm done with one function, with generating IR for one function, I lower it immediately.
Yeah.
Whereas in other cases, probably people generate IR for the entire module before and then do all of the inlining
Yeah,
stuff.
and I actually probably will lower I will lower when I'm done parsing, which will be the whole module. I could lower it function by function, except my intent is to allow inlining within a function within a compilation unit, which
Yeah,
means
the nice thing is, in my case, since everything's declared in order, it means I can compile function by function and both inline because all the things that have
right.
been, yeah.
Oh, but you end up
So,
with functions that are only ever inline that you emitted code for, but maybe you don't care. You got it in a
right,
getter function, and you're going to always inline it.
right.
But it's a getter, it's tiny. You emitted code for a tiny function. Yeah, whatever.
So this is all in the simple repository.
Yeah.
Cool.
Well, here's Levo talking about late arrivals, guys. I'm like dying here. My voice is almost gone. My throat is raw. You guys gonna show up long enough for me to say no? All right. We just talked about how to handle evil test cases where you don't emit code in orders that you would like that you see the code. Here's my version, which is the parser sees for loop, which is an iter, a test, a next, and a body, but he has to emit the code iter, while, test, then body ahead of next. which means when I come to the next code as seen by the parser, I actually literally skip it. I mark the endpoints, I skip it, I parse body and emit IR for the body, then I go back and then I parse next, and then I reset the parser. So the parser does this bebop where he skips next, parses body, emitting IR as he goes back to next, parses next, putting IR as he goes back to the end of the body and done with the while loop or the for loop. And Adrian is having a similar
So
problem where his
do you cap
syntax.
I was just going to ask, do you capture that next as a separate piece of string and then you parse
No,
that, or do you
no,
just capture the location,
just
but
capture
then
the
you have to
location.
make sure you don't
No, no,
actually
no. Big,
carry on?
big fail to copy your code blobs around. You'll die allocation deaths. Just pointing to it as a, byte array is loaded by the file system. I just load a byte array.
But you also
Right.
have to remember where to skip it once
Yeah, and then
once you last
then
pass.
the guy here going back. Okay, hang on.
Yeah.
Yeah.
I guess
Yes.
you're not dealing with any kind of streaming compile or anything, so you don't like. I mean, I know that simple is not doing anything like that, but if you were, I don't know if anyone ever does that. Like you've got like just a stream of code you're
JavaScript
comparing.
guys do. JavaScript,
Script guys do.
yeah, all their code comes over the wire. That streams in. 99%
But
of
I,
it is dead on arrival because they're loading on some dumbass library. They just need to find a particular named function, and the rest of the library they'll deal with later. So they save it all. They can go back, but they stream through until they find what they're looking for and extract it, and then they skip to the end and go to the next thing, and they're doing that in parallel with reading other stuff and whatever. Yeah.
yeah,
So I claim they're going to be doing something stupid like this, which is pauses, go read the current index into the array of bytes. That's
yeah,
all it is. And go read the current value. When, here I'm doing the next clause. I'm in a for loop. This is handled similar code for both fors and whiles. Read the pointer at the start of the next, skip a balanced expression,
yeah.
read at the end for an assert, and then a little bit down further in the same.
Oh yeah, I was wondering about that end. Yeah, it makes sense. You just get the end address and you can assert on that, and then
Right.
make sure you
So
don't
then
parse
I
it all
then I
twice.
reset position to the start of the next code, getting the end of the body code, parse an
Right,
assignment. Oops, parse an assignment. Then I check, did you get to the end? Else explode.
right.
And then I reset after the body and I carry on post body. So the parser, normally streams along. Here it stops, does a fast skip with no IR emission, does the body, jumps back, does the next, jumps back, and carries on. And Adrian was saying he's doing something similar and hates it, and I was saying I'm doing something similar and I hate it.
Right. And when you're coming into a loop, uh do you just generate the test? You just generate the test code once, I guess, right? You're not
Yeah,
going to generate it
yeah.
before and at the end of the loop. Do you
So
rotate that somewhere in a peep?
no, it's just done right here in the parser. So a for loop is there's a test in the middle. And I'm going to replace this with this. Honestly, this will just be test here.
Right.
So this
Yeah,
is,
but then I know that you'll eventually rotate that, right? You'll duplicate the test.
yeah, that goes into the land of efficient, good code gen, um, which if you do nothing weird on the back edge, which in a while loop you generally don't, the IR and the register allocator will conspire to do the right thing already.
Mhm.
Basically, you have a back edge branch. It will be empty, and you'll get a an empty loop back edge, and it'll have turned it into something that looks like a reasonable loop. If I want to get more optimization out of it, there's a little bit more work I can do, and then the loops will rotate. But that's all done by peoples and stuff.
Just a question, does it always make sense to peel the first iteration, like of the first test of the loop?
If you are running Java, almost surely it is profitable because the body will contain many loop invariant null checks.
Uh-huh.
Many loop invariant null checks. So you peel the first iteration, all the null checks happen. Now they all get killed in the body. The IR then tosses them out of the body. If you do a
I
one
guess,
pass guy, I claim that, and I don't know what your semantics are. If you're doing a one pass guy and you do have the null pointer check assertion thing going on. I claim it's probably profitable to redo the body twice, one peel, even in the first pass, and then allow or have some analysis that says all these tests have already been done. So when I'm emitting code in the body part, I'll just skip the emission of the null checks.
Yeah, I guess in my case it's more of a like a C or Rust style language, but I do have bounce checks. Maybe that could like, but I don't know
Bounce
how
checks,
often.
I have to do heavy analysis and you if you're going to have precise throw points, you need to have pre or post loops. Um,
I see.
because for instance, the obvious bounce checks should fall off the end. So the normal loop would say, and you have a post loop for that. So the normal loop says for I equals blah blah blah, but my max is the minimum of what the users put as length in and what I know the array length is. So that chops my iterations in the main loop. Then I fall into a post loop where I'm expecting to fail. And I could say I must fail. I don't have to admit the for loop, just fail. But if you the length check fails, you're just going to fail. But usually the situation is more complicated. So I emit a full for loop with range checks enabled. And the expectation is if you get into that post loop, you're going to fail. Um, but to do that,
Oh,
I have to have a check made on the main body loop. And then the same situation happens for underflow. So I end up with a pre, mid, and post. The mid gets the range checks eliminated. The pre and the post pick up those iteration counts, which I believe may throw because there's control flow in the body that may save you from edge case guarding that you can't analyze your way through. But if you can't or you can, whatever. So then the pre and the post have is iteration pieces that run the dangerous portions, and sometimes they're trivial and obvious, and you just discover that the pre and the post run 0 iterations, and the loops get analyzed away and thrown away. And that's commonly the case if you do an obvious for loop. For int I equals 0, I less than loop length, array length, I plus plus, all the pre and post iteration guys will fold away. All your element of guy for loops, the for element in loop, those syntactically sugar explode out into the same thing, and then the end cases go away as well. But people do weird shit, and you have to handle the weird shit. I have a stencil calculation. I'm looking at +1, -1 in all directions around a center point. I'm walking on my array elements when the pre and the post always walk off the edge of the array in either direction by 1, and the user's guarding it carefully, except he screwed it up, and fine. So you get cases where you emit and run the pre and post loops, and they may not fail, or they may fail, and you just can't tell. But that's the generic answer that C2 did.
makes sense. Thanks.
Yeah, there's another one it's a lot simpler, called ABCD, which came out long after C2, that does a subset of the things C2 does, but they do it with a much simpler implementation. So I don't know if it's amenable to one pass, but it's a lot simpler. I don't know if Matt, he's pulled it up before though, finds this ABCD range check elimination thing. Um, yeah, I've found an instance of it here. I'll put it in the links. Ah, da, da, da. Where'd my links go? No. Oh, here. I changed away and I shouldn't have. No, 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 no. There's probably a more official version. That's the first one Google came up with, but it's the obvious. Go figure out how you're doing eliminating array bounds checks on demand. And he does a simpler thing than C2 does, and he probably gets the 99% case also in a simpler piece of code. So I think it's a reasonable paper. I never implemented it. I looked at it. I knew it's weaker than C2. Also, it's a hell of a lot simpler. So there you go.
Yeah, that's cool. I'm always looking for these like I guess bang for buck optimizations.
Yeah,
Uh,
yeah. I got
uh,
hammered on C2 of max performance and must beat C code, and beaten on my head for a long time. So I kind of went to the limit on a couple of cases, like every C guy on the planet said, you can't do range checks, it'll kill your performance. And of course, the 99% case was easy, but it wasn't the last tiniest 1%. So I kept going.
You
And then
got
these
nerd
days it's
sniped.
like, yeah, of course, range checks. They're not hard, they're quick. I claim, sir, if you're doing range checks, you must do null checks too. Little compiler work, a little analysis. They're also cheap and give you a nicer answer than throwing a seg In particular, I'm doing it in C2 with a for where I just disallow programs that could null check, and you have to write a null check yourself. Which I need to put a thing that basically says the user believes I as the writer, the user believes this will not never null check. I don't want to write a handler for the null check. I just want the compiler to leave me alone. So I want to cast it away as a not null. But that cast point, the compiler will put a check in, and if it fails, he's at a known point and he can emit a proper backtrace, a full stack trace with any and everything for basically no cost. Or, the compiler and the user agree that we don't need a null check, and then it'll go away. So in the case of this guy, the simple for null checks, it's the full weight of the optimizer before the compiler gives up and says, I can't tell, I can't prove it. So a lot of places that in other languages that disallow nulls, you would have to put in a junk check. I don't need one because the compiler has proven it can't be null. And followed by, if I have to demand one from the user and the user puts it in, pretty much guaranteed you're going to have a null test there. Although a null test can be brought down to a cost that's much less than a clock cycle. So they're really cheap tests. All right, what else?
So just before we get off of the topic of ABCD and the C2 version, by how much is the C2 version better than, like, is it hugely better? It's just like that 1% occasional edge case or something.
It's the ABCD guys didn't handle a bunch of cases that C2 does that involve things that loops walking backwards, loops going underflowed versus overflowed, or loops that I got that started out life irreducible from inlining with trifinales for all files in your file system, do nested trifinales of file IO that throws and catches and replaces and blah, blah, blah. And I ended up with horrible loops that I had to deal with. If the range check works, it goes away. The cost is zero. If the range check fails, the cost is the extra cost plus the missing optimization opportunities. So when ABCD works, it's same as C2, no cost to the generated code. When it fails, you're probably 10% to 2x, depending on how you write your code. Like if you're writing BLAS-like routines and ABCD fails, yeah, it's probably 2x slower. If you're writing big, dirty, junk Java code where all loops iter max of 10 times and they're doing hash table on for loops on reprobe logic on blah, 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 add 10%.
Mm-hmm.
So if most loops are cut or handled by ABCD, you're good. If you happen to be the HPC guy and you need a giant array that you have to walk backwards because that's how the algorithm is going to work, like happens, say, in H2O all the time, you don't want ABCD.
I see. Okay.
But it's a stylistic thing. The loops covered by ABCD are all the easy common ones.
Mm-hmm.
It's been a while. I have to go reread to figure out where they fail over that C2 didn't.
Yeah. That's okay. I just wanted to get a rough idea of
Yeah, he's going to claim he's going to get the negative loops in this case, which he might. I mean, it's an obvious one to go handle.
Mhm.
C2 also deals with people who add to the add offsets to the indices, including offsets that wrap around the 4 gig limit, because I had to in order to get certain test cases to work. And I had to handle it so that an adversary who's trying to break your compiler would write a loop that would wrap 4 gigs or wrap 2 gigs and then pass the range check test, but at runtime, run off the end of the array.
Mhm.
And so if you took a common looking situation and declared it looks fine because the ints have wrapped in the flow analysis and I can't tell I've wrapped or anything, then you might emit code. And if you disallow this shaped loop without the right test, you would say, hey, it's an x plus y, and x is the obvious iterator, and y is the offset, and the user spammed the offset to be negative 2 billion. And my analysis is coming along and says, do min of x and x plus y less than 2 gigs. And he comes back, yes, it's all great. And what really happened is y is wrapped, and so you're fucked. Um,
Mhm.
so you end up, disallowing every common loop on the planet in that kind of situation if you disallow the hacker. So to handle the hacker, you had to handle a case where you hit edges of the universe. So I did overflow checks for the bounds cases, and I don't know that ABCD could do that. I'm trying to remember
Mhm.
what things are different here. Um, and
Right.
and and
Yeah.
the piece of paper I read says here's how you do stencil calcs, which is fine. So I don't know. There's I think you're if you're not into the I'm wildly popular and everyone on the planet's a billion times over using me and I have to be security safe, ABCD will do a great job.
Yeah. Yeah. I'm thinking that this sounds promising for what I need when we get to that.
Oh, you think you're going to put range checks in your stuff? I didn't think you'd bother.
Yeah. Well, I don't know. I mean, I don't know what will be needed. Maybe we don't even need this at all, but you know, definitely want to do some sort of loop unrolling and
Right. Well, if you don't have any range checks, the unroll situation's a lot easier.
right. Yeah. Okay. Fair enough.
And it actually doesn't make any difference. Range checks are just another part of the loop body. You're going to unroll a body that's got any control flow at all. Well, the control flow is a range check, or the control flow is user written, and your loops have control flow in the body. That happens. So you're going to
Yeah.
unroll with control flow. So it doesn't matter, range check plus or minus.
Yeah.
To do
Yeah.
the actual range check unroll smart is a bitch. You have to go find the iterators and find the induction variables and decide to get a closed form solution for them, and then figure out what it needs to be minned and maxed, and then clone the code for the pre and the post, and don't let the bodies. There's a big pile of crap in C2 for that. That's not a small piece of code.
Yeah.
It's quick compile time wise. It's fast, but it's not a small piece of code.
Yeah. I briefly looked at that part of the code base and was like, ooh, I think I'll leave this for later.
Yeah, that's a good one to leave for later. It got ugly.
Yeah.
There are some extra special things that when Bid Titzer was on, we were crossing notes of some of the worst case scenarios that he ran into. It was the same ones I ran into in C2 that I think most people missed. And here's where it gets bad. That's control flow exiting loops when you're trying to peel or clone them has to be remerged, and your control dependencies in SSA get wonkier in hell. Fine. My voice is going. It comes and goes in waves. My water is empty. The next time I start a coughing spit, I'll probably have to just call it quits. You missed function calls in simple. You missed the new shiny lattices in simple. You came in late to the party, man.
Yeah. I was debugging, but the good thing is that the bugs are fixed, so I'm
Ooh,
happy.
well, there you go. Excellent. All right. Anything else? Anyone have any other questions here?
Uh, not for me.
All right. I'm gonna bail while my voice still holds and go enjoy the rest of Thanksgiving here.
Yep. Happy rest of Thanksgiving, all.
Yeah. See people should be next week, should be fine. All
Yep.
right. Bye-bye.